Next one, we're gonna model the function using the logarithmic function. As you see the graph or the figure on the screen, you see the data, the plot of the data, and the trend of them is not in the straight line, so not the linear model. And this one is the inverse of the pattern that you saw earlier, which is in a form like the pattern of the data is increasing, but in the curve way. This one is an exponential model. And this one, since it is kind of is inverse, or instead of increasing in this way, but it looks like it's reflecting about the line y equals x. So we think about this as a logarithmic function model. To look at the definition of the logarithmic model, starting with the pattern of the function or the basic function form, is in the form of y equals the log is called log, like log base b of x. X is the input and b is the base. The assumption for the base is the base is greater than 0, not equal to 1, similar to the property of the base of the exponential function. And the x is the input, it has to be positive value. And this model is equivalent to the exponential form of b to the power y equals x. As you notice, this is the inverse of y equals b to the power x, which is the exponential model that you saw earlier. Therefore, the logarithmic function base b is the inverse function of the exponential function base b, or vice versa. The form, the log base 10 or the log base 10, it is called a common logarithm, and you can omit the base. To be understood, the base is a 10. If you don't see any number, so then the base is 10, or it's called the common log. For the base e or the base as a natural number, we can write the log as a ln, which is from the natural log or the log base natural number, n from the natural, which is the base, and the L is from the logarithmic form. So natural log or the log base e or log base natural number e. In this example, we are going to sketch the graph of y equals log base 2 of the x. And we call the log and the exponential, they are inverse of each other. Before we sketch the graph, we're gonna use the relationship that the function y equals log base b of the x is equivalent to the form of the b to the power y equals x. Is more convenient when we compute using the exponential form. In our case, the b is 2. So then we can rewrite this as, I'm gonna write as this is a y, okay? We have y equals log base 2 of the x. So we can rewrite it in the exponential form as the base 2 to the power y equals x, or x equals 2 to the y power. It looks like we're gonna need the input as a y and the output as a x. So we're gonna start with the column y as an input and then get x out as an output, and then put together in the order pair to get the order pair x comma y before we plot the points on the xy plane to get the graph of it. From the relationship that x equals 2 to the power y, y is the input. So for y negative 3, x equals 2 to the power negative 3. Y equals negative 2, x equals 2 to the power negative second. And do it the same way for the rest of the table. Then simplify the numbers. 2 to the negative third is 1 over 2 to the third, which is 1 over 8 or 0.125. 2 to the negative second is 1 over 2 to the second, which is 1 over 4 or 0.25. 2 to the negative first is 1 over 2 or 0.5. 2 to the 0 is 1. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. Now we get the column for the x completed. We're going to put them together in the order pair. And the order pair x comma y is 0.125 comma negative 3, 0.25 comma negative 2, 0.5 comma negative 1, 1 comma 0, 2 comma 1, 4 comma 2, 8 comma 3. We get the set of the order pairs. And next we're gonna put our order pairs and plot them on the XY plane. The tip and techniques to sketch a graph. From the list of the XY coordinates, make a list what is your X minimum value. X minimum is 0.125. The X maximum is the value 8. The Y minimum is the value negative 3, y maximum is positive 3. So then when you sketch the graph, make sure your graphing area covers the x min, x max, y min, y max. And what x min, x max are positive number. Y min, y max range from negative side to positive side. So we're gonna have the graphing area, which is on the right side of it. Okay, this is origin 0, 0. This is the x value, and this is, the x axis, and this is the y axis. So the x min is 0.125, the x max is 8. So make sure you have the scale to cover the value x equals 8. So break it down. So this is 2, and this is 6, and then 1, 3, 5, 7. And for the y, the lowest is negative 3. The highest is 3. And next, we're going to plot the order pairs on the xy plane. The first one, if x is 0.125, y is negative 3. So it's very close to the y-axis. Next one, x is 0.25, y is negative 2. And next, x is 0.5, y is negative 1. X is 1, y is 0. X is 2, y is 1. X is 3. No, x is 4, y is 2. X is 8, y is 3. So the graph is increasing, but in different behavior than the exponential graph. So now we have the graph of the function y equals log base 2 of x.